Howdy folks, Mr. Reed here, and welcome to one more question. So today, what we're going to be taking a look at is finding the intersection between two functions that have radicals in them, actually both of them having radicals in them. And not only that, but there's going to be a radical plus or minus some value. What it's going to end up meaning is that it's going to take more than one step to solve this thing. So I'm going to say that this one's spicy. It's kind of a lot of the same thing, so it's not really an understanding level of spicy. It's more that the algebra gets a little bit messy if you don't know how to deal with it. So if you want to see solving radical equations in a spicy manner, then you've come to the right place. Let's get to it. Okay, so as always, I'm going to just copy down what's going on up there. So it's f of x is equal to the square root of x minus 2 plus 2, and then my g of x function that I'm going to set that equal to. You know what? I'm going to just say that this is equal to, and g of x, which is negative square root of 11 minus 3x plus 4. So I'll just kind of say it in one line. I guess I could have gotten rid of the f of x there at the beginning, and that would have been fine. Whatever. So the biggest problem here is that our method so far has been to isolate for the square root and then square both sides of the equation. Now, there are actually two square root functions here, and so even if I collect a little bit of what's going on here, so if I just say that it's x minus 2 and I leave that all by its lonesome, and we say on the other side we get negative 11 minus 3x, and then I subtract 2 from both sides, so I end up with a plus 2 over here. It's kind of nasty. Actually, I probably may regret which side I ended up putting that on, but it doesn't really matter in the long run. So I'm going to square both sides anyway, because there's not much I can do other than getting rid of the square root symbol that is on the left-hand side of my equation. On the right-hand side, because of distributive property of binomial multiplication, I'm going to basically have that bracket of two things, which is the negative square root of 11 minus 3x plus 2 times itself. So I'm going to get my first term times my first term, first times second, second times first, second times second, or however it is you like to think of the distributive property. But it's going to create some square roots still after we've squared the whole thing. So we'll go ahead and do that. I'm going to just get the nice x minus 2 on the left-hand side. And on the right-hand side, I get the first thing squared and the last thing squared, and then 2 times the middle crossover going on there. So I'm going to just write it as 11 minus 3x. And then I'm going to say that it's minus 4 times the square root of 11 minus 3x. And then I'm going to add a little further there. And then I'm also going to have my plus 2 times 2, which is 4. So I'm going to now have just a single location where there's a square root function. So in this case, I am going to isolate for that single one and then square both sides all over again. So what do I have? On my right-hand side, I have, let's actually start looking at things a little bit more carefully. I have an 11 and I have a 4. So I have 15. I'm going to subtract that over the other side and get negative 17. Okay, so I'm going to have that, but I'm also going to have adding 3x to both sides. So I'm going to have 4x minus 17 is equal to negative 4 square root of 11 minus 3x. Okay, now I could divide that negative 4 over onto the left-hand side. Sadly, the value there for negative 17 isn't going to divide it evenly, so it's okay, but it's not really going to clean things up no matter which side I put it on. So I'm going to go ahead and square both sides. So I'm going to get 16x squared minus 4 times, this would be 68, then times 2 would be 136. Ooh, I better be right. All right, minus 136x plus 17 squared. So that is going to be 289, I believe. All right, on my right-hand side, I'm going to have negative 4 times negative 4 is 16, and then the square root times itself is going to get rid of that square root value. All right, now I'm going to group together things as best we can on the left-hand side of my equation. So I have 16x squareds, and I have another from my right-hand side. So I'm going to kind of show where this is coming from. I'm going to have another negative 48x's, so I'm going to add that to the other side. 48x's should leave me with negative 88 left there. And then I'm going to have 176 on this side, positive. Subtract from the other side should leave me with 106, 113. Who made this question up anyway? I obviously don't like myself very much. I'm hoping that this works out okay. So I'm pretty confident that there is no common factor between 16, 88, and 113. 138, or 113 looks prime to me. I may be wrong on that, but it's definitely doesn't share any nice factors, I believe. So I'm just going to go ahead and use the quadratic formula. So my x values are going to be negative the coefficient in front. So have it written in descending order. So I have my x squared terms, and then my linear terms, and then my constant terms. So I'm going to say negative b is going to be 88 plus or minus the square root of b squared. Yeah, we're just leaving that as an 88 squared. I guess it would be 6400 plus 64 plus 80 times 8 would be 640 times 2. So it'll be 1280 plus 6400 plus 64. I'm not very good at adding. I can multiply some things in my head, but remembering the things to add, not so good. I have a calculator beside me. I'm going to end up using it to finish this one off. So we have b squared minus 4ac all over 2a. Now, it would be best of me to actually evaluate this in as an exact value. I think I'll do that, but I won't bother simplifying it, so just to keep things a little bit shorter. So I'm going to keep the 88 plus or minus the square root of, and I'm just going to put in whatever the value is. So that ends up being 88 squared minus 4 times 16 times 113. And so that would be 512 under there. Oh, it's a nice number. I should just do stuff with it. I'm not going to. I'm going to leave it the way that it is. So I am going to get the decimal approximations for these two values, because I'm going to feed it back up into my statement that is way up here at this point. I'm not going to actually do the original because there's a very, very small change between the original and this line. So that was just subtracting 2 from both sides of my equation. I'm going to pop it into that. If these numbers both work, then that means I should have 2 solutions. If neither one of them works, then I have no solutions. And then it might be that just one of them works. And that wouldn't be super shocking, because if you kind of think of the way these look, you're going to have a function that looks like, I'm not looking at the transformations. You're going to have something that's either top or bottom half of a square root function. You're going to have another one. So maybe they cross like that, and you just get 1. There's a chance that because of the stretch of what's going on, you could have one that kind of like cuts through the other one like that, and that would be fine. And you could have them totally miss each other. So I don't know right from the get-go which of those cases I'm going to see, and I'm not too worried about it. But let's actually go ahead and evaluate this. So I'm going to go 88 minus the square root of 512 over top of 32. So that would be an x value of 2.04. Just going to round it to the hundreds position. That should be close enough for me to feel comfortable, I guess, about the values there. So 512 divided by 32. And my other one is 3.46. Okay. So my negative root was first, my positive root was second, and those are my two values. So let's go ahead and throw these into my original statement. So if I just evaluate the left-hand side with the square root of square root of 2.04 minus 2. That's actually kind of interesting because it's going to be very small. 2.04 minus 2. My apologies, I typed in the wrong thing. So I get 0.2, of course. So 0.2 for what I get on the first side using that first number. And on the other side, I'm going to get the square root of 11 minus 3 times 2.04. Well, I didn't use brackets. So let's try that one more time. 11 minus 3 times the 2.04, and then we'll take the square root of that. And we'll throw a negative sign on the front, and we will add that to 2. And so I end up getting, in that case, negative 0.21 if I'm rounding. But as I said, I rounded to the hundredths position for these two values down here. So I'm going to have a little bit of wiggle room when I start to verify the values. But I wouldn't be too upset if it was 0.2 and 0.21, or 0.20 and 0.21. The problem here is that one of them is positive and one of them is negative. This is a pretty common thing that happens when dealing with roots, because if you have a positive root squared or a negative root squared, the algebraic difference between the two after squaring it is nothing. So the algebra will be kind of following through that it could have been originally positive or negative. In this case, for them to have been equal, they probably would have had to have been the same sign for this number to have worked. Because of that, it doesn't end up working, which means graphically this is going to be one of the cases that has maximum one intersection point. Fine. Now we'll just go ahead and try the 3.46, and I'm actually feeling really good that it did give me almost the same value, positive and negative. That's a sign that things did go well. I'm hoping with the 3.46. I did graph these before I started, so I know that they do have one intersection point. I'm hoping this is it. So here we go. 3.46, subtract 2, and we're going to square root that thing. And we get approximately 1.21. On the other side, we're going to have 11 minus 3 times 3.46. We're going to square root that and throw a negative on the front and add 2 to it, which gives me 1.21. Perfect. And if I took it to the hundreds position, they would have been off by a little bit. They end up being the thousands position, they would have been off by a little bit. At the hundreds position, they end up being the same value, which, again, that's great. If it had been off by a single hundredth, I probably wouldn't have blinked at all. I would have been fine with it, just because I wasn't using the exact values. I could have, but I didn't even bother simplifying my exact values first. I probably could go about doing that now that I know that it is the right answer, or at least it verified well. But I'm going to leave it the way that it is, because this has already kind of just been me fumbling around with some numbers. So long story short, the method of solving something like this is to take, simplify as much as you can to begin with, and then you're going to square both sides, which is going to create more square root values. It's unavoidable, that's fine. So we are going to then rearrange our equation to isolate for the single square root that will be left after the first squaring. Next time on the second squaring, we're going to end up having no square roots left. So no x's trapped inside square roots. You can set up a quadratic out of the stuff that's left. Solve the quadratic. It's ugly, so we use the quadratic formula. Got some roots, verified, and we are good to go. So our final answer, would be that x would be equal to 3.46, and the 2.04 is actually an extraneous root. All right, deep breath. That's the nastiest number thing that I've done so far in this series, but that's okay. I should probably get used to doing stuff like that on the fly. Sweating a little bit in the mid steps, hoping that things turn out all right. That was actually a one take, so I'm happy. If it was helpful to you, like, subscribe, and as always, take care, folks.